Hey everyone, and welcome to our DevTalk webinar, To Rebase or Not to Rebase, Taming Your Git History. This is going to be a 30-minute presentation today, and then we'll be leaving some time at the end for questions. So use the Q&A widget to enter those questions, and we'll have John, our presenter, answer those at the end. I'd like to introduce you to John Williston. He's a veteran software developer and Git expert who recently joined Perforce as a developer evangelist. So with that, I'm just going to turn it over to John.
Thank you, Natalie. Good morning, all. Good evening, or whatever it is where you're at. Today's agenda is to talk about rebasing, and we'll start by answering the obvious question, what is rebasing? Discuss how it has led to a certain division in the Git community, and then try to answer perhaps the more important and practical question, should we rebase? And how should we go about rebasing if we do? There are a variety of factors to consider, and we'll discuss those. So, starting with the question, what is rebasing? It's probably easiest to define rebasing by telling you first what it isn't, because what it isn't is something you're more familiar with, that is, merging. Merging is the way that version control systems have brought code from one divergent branch back to another, at least as long as I've been doing it. And as much as I hate to admit it, I still remember when PVCS was the new up-and-coming kid on the block, so I've been doing this for a while. Merging is that process by which you have one divergent code line that has broken off at some point from your master or your main branch or whatever branch, and you now need to bring that work back into the fold. Sometimes that's for testing, sometimes it's for release, whatever the case. Merging is the process that you use, and merging is all about integrating one set of files into another location. Git comes along and upends this a bit insofar as it provides two different mechanisms for bringing work back into the fold. The first one is the one we all know and love, merging. The second is rebasing, that we're talking about today. And in contrast to merging, rebasing is really more like a macro. And I say that because just as in a code editor or Microsoft Word or some other application package in which you might record a sequence of steps and then play them back one or more times, well, that's essentially what rebasing is. When you merge, you're taking the contents of one branch and you're integrating it back into the other branch. When you're rebasing, you are accumulating a series of changes into a single patch and then replaying that patch or macro on the target branch. And given that description, the obvious question is, okay, so why do I care? Why do I need rebasing as opposed to merging? Well, rebasing also flattens history in the process, and that's really its reason for being. So let's try to contrast these things with in a few different ways. So first, merging is a three-way process. So again, you have a branch, another branch breaks off from it at some point. When it's time to bring that work back into the fold, you're now dealing with three different sets of files. The original common ancestor from the point at which your branch broke off, the head or tip revision of your source branch that whose work you want to bring back into the fold, and then the master branch, and where its files are at that state and time is a wholly open question. So merging is always a three-way process. In contrast, as I said, rebasing is more like a macro where you record a set of changes and play them back in another place. So one of the implications here that isn't all that subtle is that merging is usually about collapsing one divergent branch onto its ancestor. Whereas with rebasing, well, you can rebase anything on anything else. So just like a macro, you can record it and then play it back multiple times. So rebasing is one of the tools in your Git kit to take code from one place and put it in a completely different place. At the end of that process, the files on your target branch should essentially be the same whether you've merged or rebase. But as a side effect, merging preserves history. Your source branch files remain unaffected. You still have all your work there. You still have all of that history there. But rebasing destroys that history. The branch that you have chosen to use as a source for rebasing now lacks all of the commits that used to be there. And whereas with merging, only the target branch is updated, with rebasing, both branch pointers end up being moved. So that's a pretty textual description. Let's take a look at a picture that might help illustrate this a little better. So before we're going to integrate code, this is a very small, very simple, trivial case, and all of your real-world cases will surely be more complicated than this, but it's the smallest case that illustrates a need to merge or rebase. So here we have a code line, a branch, starting with commit 1. You do some more work and make commit 2. At this point, for whatever reason, someone decides, hey, it's time to go make a different branch, and thus commit 3 down and to the right is born. Now that may be because an experiment's going to be conducted. It may be because you need a new version of your software. In this particular case, the branch name I chose, seen below, is bug fix. This is a common workflow in Git. You have a bug to fix. You might as well do it on a branch so that it's completely independent of all your other work. In such a scenario, commit 3 then establishes this new bug fix branch, and in the meantime, a colleague, or yourself if you switch back and forth, will at some point, no doubt, commit more work, commit 4, on the master branch. So here now we have a divergent series of branches or code lines, and we need to bring that work on the C3 bug fix branch back into the fold. The next slide will illustrate the differences in the two ways of doing this. To the left, we can see merging, and that is the classical diagram with which I'm sure all of you are probably familiar. This series of commits, C1, C2, then our divergence in C3 versus C4 is brought back into a single commit on the master branch. And I would call your attention to the fact that the bug fix branch pointer down below still points to C3 even after the merge. That represents how your history is preserved by merging. You had 2 divergent code lines, just like a twig, branches off from a tree limb, and now you've brought them back together into C5 through merging. With rebasing, the very same set of initial conditions lead to a very different outcome. We have rebased the bug fix branch onto the master branch, the result of which is we still have commit 1, we still have commit 2, we still have commit 4 on the master branch because that's our target branch, but C3 is nowhere to be found, and the bug fix branch pointer now points at C5. In effect, we have obliterated all of the commits on the bug fix branch, or if you prefer, we've squashed them down into a single commit that is now seen synonymously with the master branch as C5. Now, it might seem reasonably innocuous, but rebasing has therefore set off a certain division in the Git community. It is a point of contention as to whether you should or should not rebase and why. So let's take a look at the two camps. First of all, let's establish from the outset that both camps have good reasons. It's an easy thing to dismiss somebody else's view of the world, but in this case, the always merge side of the fence has clear positives in their side just as the always rebase camp has clear positives on their side. Both agree on at least some of the problems with rebasing as a strategy, but in any development organization where you have both, you will have a productivity hit as the two will disagree. So it is important that we find common ground, or that we establish a strategy that we can all live with. And so let's look at the points that these two camps have on their side. Beginning with the always rebase camp, their first and perhaps best argument is that it eliminates complicated history. As we could see in the graphical representation, we had a nice linear series of commits after the rebase, unlike the merge, where we still had that divergent branch and then a merge. In particular, this can be a problem with busy repositories and busy branches, because when one developer is ready to push his work back to master, if another developer has already pushed work to master, then he will find out when he goes to push that this has happened, and he will need to do a pull and then do what's called a merge commit. And so what this ends up producing in busy repositories on a busy branch is what you might call merge commit noise. It can be very significant. In fact, in busy repositories with busy branches, you can find that the majority of your commits end up being merge commits. Then the result of that, if you go and look at the branch structure, is what you might call rainbow branch diagrams. You know, graphical tools tend to choose different colors for one branch to the next, and so in a busy repo on busy branches, with busy branches, you end up with this rainbow diagram of all the colors of the rainbow next to each other, showing how there have been so many branches and so many merge commits. And so Rebase is a solution for this, because rebasing squashes those intermediary commits down into a single commit and removes that branch history, so that what you're left with is a nicely linear, uncomplicated history in comparison to merging. Rebase, in effect, cleans intermediary commits, and this is a big deal, particularly for organizations whose DevOps teams have policies in effect to ensure that every commit made to a public branch or a certain place is supposed to have proper unit tests and supposed to be clean so that it doesn't break the build for everyone else. Rebasing, as when used properly, can clean the sort of intermediary commits that can otherwise cause problems if at some point in the future an intermediary commit is pulled and built. It can squash down all of that stuff into one single commit and sort of reduce the noise. So that's really the main argument that the always rebase camp has going for it is it's simpler, it's clearer, it makes everything better. Now in contrast, of course, we find the always merge camp. And first and foremost, you have to grant that merging is simpler and more familiar to most developers, I think anyway, than rebasing. Now this may not be true anymore. The current generation of developers coming up out of university, steeped in Git and knowing nothing else, thinking in effect that version control just is synonymous with Git, that's what it is, maybe they don't feel that way. But from the last several decades of experience, I've seen merging in every version control system I've ever worked with. I've only seen rebasing recently come to the fore in Git. So if nothing else, it's certainly fair to say that merge is not new and different like rebasing. It has that on its side. Also on its side, the merge advocate can say, rightly, that it preserves a complete history. All of those intermediary commits that go away when rebasing are still there with merging. So if you care about not just the endpoint, but the process of getting to the endpoint, if the travel is as important as the destination, merging preserves that travel. You can see the evolution of thought and idea expressed in code in that series of intermediary commits. Merging also preserves chronological ordering, and this is a problem that folks don't realize when they start rebasing, at least not usually. And that is that with rebasing, it's possible to create a nice, wonderful linear sequence of commits in which chronological ordering is not preserved, meaning you can have an earlier commit with a later time. It's a problem that rears its head about the first time somebody tries to use git bisect to find where some problem snuck into the code base and ends up beating their head against it for a while until they realize, oh, that's right, all of that work was done, it was all squashed down to the one commit, and so we have a time here that is not in linear sequence. Tools that work with that sort of thing can be thrown off in light of rebasing. So it's one of those hidden gotchas that you'll run into eventually if you're rebasing frequently. Finally, the merge folks have no hidden problems from pushing. This isn't really a hidden problem. I suppose that's probably an iffy choice of language. Even the Git book describes the perils of rebasing on branches that you're pushing. The scenario starts out this way. You make a branch for some experimental feature. You work on it for a while. Then you send it over to someone else to take a look at. He gets a pull request. He starts looking at that code. The two of you collaborate on it. If at that point you then go back and rebase history, well, now you've affected the other, because the next time he pulls, he's going to find out that what he has in his repo no longer reflects what you have in your repo. That's one of the dangers of destroying history. So when you're rebasing, you have to be a lot more careful about where you push and what you rebase. If you stick with merging, you don't have these kinds of hidden problems. You still have, of course, merge commits where you go to push and discover someone else has already pushed changes. But you get that either way. At least merge has no hidden problems, so say its advocates. So let's take a few key observations from this. First, history is a first-order work product. The code that you're developing is not just what you end up with. How you got there ends up being relevant. A series of commits in your public version control system need to be good commits. They need to build with your continuous integration system. They need to have clear comments. They need to be tied to job IDs or whatever it is you're using to track work. History is a first-order work product, and we can't be cavalier about it. Either way, wherever your sympathies lie, developers have a professional responsibility not only to deliver the value that they're being tasked with creating in terms of new features and bug fixes. Part of their job is to consider how they're getting there and in the end deliver a meaningful sequence of commits that is valid history. So history has to be considered. Second, I think both camps grant that merge commit noise can drown out the signal. In a busy repo with busy branches, you can end up having a majority of your commits being nothing more than merge commits, because one developer goes to push and some other developer has already pushed. That can end up giving you a lot of commits that are nothing more than, hey, I'm merging work. And this effectively then helps mask the commits that matter, so to speak. Both camps can also surely agree that rebasing privately affects only the individual. In other words, as long as you are rebasing only on branches that you aren't pushing anywhere, well, then you're affecting nobody other than yourself. And finally, this is where many of the problems with rebasing show up in teams, is that rebasing publicly affects others. As soon as you go rebasing that branch that you've shared with someone, or as soon as you try rebasing a branch that other people are pulling from, you're going to hear about it, and probably via the form of, death threats and other vile imprecations. We hope not. So having said all of that, we're faced with the question, should we rebase? It's obviously a powerful tool. Should we make use of it? And if so, how do we make use of it? Well, let's draw some initial conclusions. First, I don't think either of those two extremes is necessary. the always rebase camp or the always merge camp, I don't think you have to adopt an either-or sort of position. I think that's a false dilemma. Second, rebase simplicity effectively ends where teams begin. In other words, an individual rebasing private branches isn't hurting anybody. Rebasing really only becomes a problem when you start to rebase among people on public branches. Individuals aren't teams. Why should a need for team policy necessarily affect or set individual policy? Developers who are more comfortable rebasing can do this in the privacy of their own work area as long as they don't affect others. And clearly, team policy does remain essential because at the end of the day, we don't want a bunch of friction. We don't want our productivity sapped by arguments over always rebasing or always merging, and we don't want this kind of friction. So, having drawn the rather obvious initial conclusions, let's suggest that for individuals, branch for every unit of work. The only time you're going to cause others problems with your rebasing is if you're rebasing things you're making publicly available. So when you're beginning a new unit of work, the easiest way to make sure you're not affecting anybody else is to begin it in a new branch. And after all, this is Git. So branch again. If you're beginning a unit of work and you don't know quite which way you're going to go with a feature at some point, well, branch again. See, Git is all about branching. It's really its reason for existence. When Linus Torvalds, announced Git and discussed its history, he pointed out that branching is easy in Subversion, but merging things back together is not easy. And this is why Git's branching and merging and rebasing are designed the way they are. Git is designed around branching frequently and branching for every unit of work and then using its powerful tools to bring this stuff together. So when you have a unit of work, branch for it. If you need to experiment, branch again. And commit as often as you like on these. I'll confess I'm a little OCD, and one of the things I like about Git is that I'm working locally. I can commit constantly. I can commit little units of work. And this is one of the things that I really appreciate about Git, because unlike a version control system with a central server where anything I submit goes to everybody, I don't risk breaking the build. I don't risk interfering with others' work. I can commit as often as I like. And with rebasing, it gives the power to clean up that history prior to review. If my experimental branches didn't pan out, well, then I don't have to push them. If an experimental branch did pan out, okay, then I can squash it down to a single meaningful commit or a series of commits and make that history nice before I do go pushing back to the public repo. Finally, in order to avoid messing up the work of others and breaking the build, I suggest that the individual stick to merge when dealing with others, because after all, merge doesn't have those kinds of problems. If you have a branch where you're not sure, hey, am I going to work with individuals? Does this need to grow with others? Then just don't rebase. It's easier that way. Branch privately, rebase there, and deliver as needed. When it comes to teams, it's not quite so simple. So there are a variety of questions I think you have to address, and these are the four that jump to my mind. First, what is your team's rebase competence? Let's be honest, all men may be created equal, but all developers are not equal. Some folks are just better at Git than others, and you have to take that into consideration. If everybody on your team is a Git wizard, then this is going to be old hat. If they're not, you can run into issues when they start rebasing. Second, what's your organization's Git competence? Because after all, your developers aren't the only people who are going to be affected by this code base. Your DevOps people, QA for their testing, pre-production, everybody is going to end up inheriting the choices made by developers upstream. It has to work for all. Which do you value more, simplicity or traceability? If simplicity is your thing, then Rebase is your friend, but some folks work in heavily regulated industries or elsewhere where traceability, where software archaeology is more important than mere linear, simplicity in your code lines. And finally, does your branching strategy fit? Branching is something that has to work throughout the organization so that development isn't holding up QA, that QA isn't holding up pre-production. You have to have these things working in such isolated ways that each team can continue doing its thing without interfering with the other teams. So, final conclusions here. Rebase is a little like fire. As I think it was Washington who said of government, it can be a dangerous servant and a fearful master. But when used properly, it does streamline and clarify history at a certain cost. Competent individuals should freely use it. There's really no penalty as long as you're using it on your own stuff. There's no problem. Yes, you can accidentally destroy your own history, but that's a little like shooting yourself in the foot. Teams need to be sure it fits. And with some clear guidelines, as we've discussed today, it can fit. Individuals can continue to use it without messing up their teammates. And finally, organizations just generally need clear branching strategies, especially when you're using Git, since its very reason for being is better branching. So I hope that's been an informative presentation for you today. Let me toss that back to Natalie and see what questions we have.
Hey, thanks, John. So that was a lot of information, great webinar. I'm sure you have a lot of questions, so please use the Q&A chat window to send those in to us. We already have a couple. Looks like the first one here is some teams are using Perforce and some are using Git. Is there a way to have shared history between them?
Yeah, absolutely. Our Git Fusion product provides a system so that Perforce repositories serve as the single source of truth. Everything can be kept in your depot, but developers using Git can simply clone as if they were using plain old Git. And the reason is because Git Fusion effectively provides a Git front end that makes sure that everything you do in Git goes to the back end. If you're interested in that, go to the website and take a look at Git Fusion. That can absolutely unite both Perforce developers and Git developers.
All right, it looks like we have a question about Agile. How does rebasing align with Agile methodologies? It seems to me it diverts from the iterative process because the interim work products are lost after rebasing. Do you have any thoughts on that?
Yeah, first of all, that's an insightful question. Thank you, whoever offered that one up. Second, I don't think that rebasing is really at odds with an Agile methodology because I don't think Agile methodology comes down conclusively on either side of that question of how important your history is. Agile is an iterative development methodology, so you have your sprint process, you're trying to achieve certain concrete goals as part of that sprint. But I'm not aware, at least not in the Agile Manifesto or the other reading I've done or the Agile teams I've worked with, that necessarily you must preserve every individual commit along the way. So you're going to work on small chunks of work. You're going to work iteratively, yes, but there's nothing wrong with an individual developer certainly using experimental branches and rebasing them back to the target branches on which he's supposed to deliver. I don't think there's really anything wrong with a team saying, okay, we've done our sprint. We know we've got all our features. Man, that history is complicated. Let's squash that down before we push it up to master. Again, it's going to depend on your industry and how much you value simplicity versus traceability, but I don't think there's an obvious, oh, we're using Agile methodologies, therefore we must not rebase implication. Great question.
Great. Looks like we only have time for one more. There's some questions here about branching strategies. Which types work best for different organizations? Can you just elaborate on that section a little bit?
Yeah, sure thing. The key to a branching strategy in an organization is to shape it around the teams and how their work is to be organized in parallel. For example, I can think of a job I was at where on an almost daily basis, the head QA guy would come into the development part of the room and say, hey guys, you can't commit anything because we're trying to do our testing, so don't commit anything, we're doing a build, it'll break. And so you've got a bunch of developers who are now stuck with code sitting on their local workstation trying to figure out ways to make that work. Thankfully, Perforce gives you features to do that, like shelving and whatnot, but a better solution, And the solution I pushed for at that job was to have a better branching strategy so that you have a branch on which your developers are working. Individual developers can have their own branches under that, so they're working in isolation. For that matter, they can have multiple layers of branches under it for experiments and other things. But the important thing is that work from that development branch for that particular release or feature is only delivered to the next branch when it makes sense. That isolates those feature teams from the whole main line from development, which isolates that from QA, which isolates QA from pre-production, which isolates them from production, the result of which is that your branch strategy ends up reflecting the shape of your organization so that your teams can continue working with maximal effectiveness and parallelization, if I can actually pronounce that word.
All right, excellent. That's all the time that we have for today. We will be sending out a recording of this webinar, and we encourage you to share it with your colleagues. You should be getting that around the end of the week. We'll also send out a link to a PDF of the slide deck. And if we didn't get a chance to answer your question today, we will be following up with you just to make sure that you're getting the information that you need. So thanks again, John, and have a great day.